Hey everybody, so in this video I'm going to be going over the Easy Crypto Challenge I'm gRoot from the 2023 Hack the Box Business CTF. And the cliffs, if you're just here because you want to know what you're supposed to have done, in the Merkle Tree implementation that they're using with the security flag set to false, we can just perform a second pre-image attack and concatenate two of the leaves, and we'll end up getting the same root hash. So jumping into the source itself, we get two files, this utils.py, which is just a bunch of helper functions, and then the actual kind of code itself. If we look at what's going on, we're creating this blockchain, we're initializing it, and then we're mining blocks. And essentially what this is a block is just a list of transactions. And a transaction is just a dictionary with a, well, not a dictionary, but it has a from, a to, and a signature. And a signature is just the SHA-256 hash of who it's from and who it's to concatenated and hashed. So a block is just a list of transactions, and a transaction is just a to, a from, and a signature. Now the blockchain is a list that is going to contain this object that I'll talk about in a second. But essentially what's going to happen when it creates this blockchain is it creates 3 blocks, and then each block has 8 transactions in it, and a transaction is just a random from and to. And then those transactions get added to the block, and when the block is mined, what it's doing is it's creating a Merkle tree. It's appending each of the transactions to that Merkle tree, and then it's taking that root hash. And so what a blockchain is going to be a list of the information of each of these blocks. It's going to record what the block number is. It's going to have all the transactions that are in that block, and it's going to have what the root hash of those transactions are. And so what the code we interact with is we can have it list out the mine blocks. So we'll get a list of those 3 blocks that'll tell us, what block number, all the transactions in each of those blocks, and then the root hash of those transactions for that block. And then what it's going to ask us to do is it wants us to give it a list of signatures, and then it's going to compare our list of signatures from the list of signatures in the last hash, or in the last block. So we see it's our signatures versus their signatures, and it just compares them. And if they're the same, the program exits. If it's not, then what it's going to do is it's going to test them. So it's going to take the signatures we give it, and it's going to create another Merkle tree. It's going to append all those signatures to it, and then it's going to get the root hash, and it's going to compare if the root hash of the signatures we give it is the same as the root hash of the signatures from the last block. And if it is, we get the flag, and if it's not, then too sad, or too bad, so sad, try again. So we need a way to give it different signatures that end up giving it the same root hash. So this challenge kind of hinges on understanding a Merkle tree, which, if you're not familiar with, is essentially just a data structure. And these leaves here are the list, or the transactions, and what it's doing is it's going to hash, it hashes this leaf, hashes this one, then it's going to concatenate these two and hash it, concatenate and hash. So essentially what you have is this root hash here contains all the information, like it's affected by every leaf below it, or every node below it. So if you change any of the transactions, which in our case there's 8 of them, if you change any one of those, then this root hash is going to change. So we need a way to give it a set of transactions that's different, but we'll get the same root hash. Well, one thing that might have led you to the path of what to do if you weren't familiar or haven't done anything like this before is this security equals false thing. That probably should have caught your eye, right? Because we're trying to do something insecure, and here we're saying hey, let's not use security. So what you would want to do, the path I think that would be the easiest path to get to how to do it. If you're unfamiliar with all this, is like, let's just look and see what's going on with that flag, like what's happening. So if we see the Merkle tree, they're using the package called PyMerkle. So if we actually let's just Google PyMerkle and look at the documentation. And I'm actually going to do the GitHub just because there's a broken link that we're going to want to visit in here, but it's the same thing. So if we look at it, it describes it, talks about it, and then we get to the security thing. And then it talks about like resistance against second preimage attack. Well, we're trying to do some kind of attack. So even if you're not familiar with what a preimage attack is or second preimage or whatever, like, again, this should catch your eye. And it tells you right here, like, oh, go here to see how to perform against a root hash against our Merkle tree implementation. And it actually kind of lays it out for you what you need to do. If the security attribute has been set to false, which, hello, that's what we have, then it's telling us that this is possible. So the way this attack works is essentially what you do is like, this is our transactions, and then these are the hashes of each. Well, let's just eliminate the last two. We'll go ahead and combine that information ourselves and pass it in. So instead of giving it, our tree we have 8 transactions. So instead of giving it 8, we're going to combine the last 2, hash them ourselves. We're going to just basically do all this for it, and we'll give it this. So we're going to give it 7 transactions instead of 8. And the security false means it's not going to check the size of the tree or anything. So it's not going to care that, hey, these trees aren't the same size. We're going to pass, that'll allow us to pass this check, right? Because we're not giving it the same set of signatures, right? One of ours is different. We don't have these other two. So it'll pass this, but it'll end up giving it the same root hash. So, and I didn't really look at this, but you might even have been able just to like copy and paste and use this. I don't know. Or, you obviously have to add the transactions and whatnot. But if we're going to just do this manually. So if we connect to the challenge Docker that's running, we want the information of these blocks, right? Here's the last block. So this is the set of transactions. This is what we're going to work with. So let's call it, I could just copy all the transactions. Right, we want to take the last 2. So we'll call it, what is that, T6. And transaction. And I'm off by 1 because it starts with, it's indexed at 0. So T6 is actually the 7th transaction. T7 is actually the 8th transaction. So like we look, T7 is that same last one. So what we want to do then is we're going to import SHA-256 because we're going to hash these ourselves. So what essentially we're going to do, we're going to forge our block, right? And yeah, let's just go and do it this way. And we want to hash. Oh, actually, first off, hold on. These are hex strings right now, and we hash on bytes, so we need to convert these to bytes. So we'll say T6 equals right. So now we have bytes, and then T7 is equal to. So now what we want to do, our forged one is going to be the SHA-256, the hash of T6, and we want the digest of that, plus the hash of 7th and the digest, and those are just added together or concatenated, equal sign. So we see we've hashed them and concatenated them. So we want this to be in hex now, because we're giving it hex strings back to the server. So now we have this right here. We went ahead and hashed what C and D would. We combined them together. So we're giving it this. So we're giving it the 6 other ones, and then our last one will be the combine, and it's going to end up giving us the same root hash, assuming I did all that right. So let's go ahead and let's see. We want the input we're going to give it be the first. I can't remember if it includes the last one or not. Let's see, length. No, I don't want that. I want this. And then I'm going to append. So this should be the first 6 transactions, right? 4, 6. So it should be not this one, not this one. There we go. And we're going to append that one we forged. So now we have 7 transactions. So we're going to pass the check because it's not the same set of transactions from the other one. Let's just go ahead and join these, because this is what I'll paste in. Oops. So now we want to forge. We're going to give it what we've done, and we see we get the flag. So hopefully that made sense. If not, definitely encourage you to read up a little more on Merkle Trees, second pre-image attack, yada, yada, yada. Yeah, so hopefully if you're still here, you got something out of this. If you did and wanted to like or subscribe or any of that stuff everyone's always asking you to do, that'd be great. Otherwise, yeah, thanks a lot.